Okay, hi. So what I'm going to do is a very brief video on how to draw out some kind of logic expression. So we can say that we can describe a logic circuit by some kind of functional expression, right? And if I was to just do a random one, I could say f, which represents the functional expression, is equal to some inputs. We have A or B not, and then in brackets C, D, or not C, or B, C. So let's just think about this term for a minute, right? So I can see that this is actually constructed from many different components, right? If I was to look at this, I can see that the plus symbol, well, we know that this is an OR gate. We know that this bar up here represents a NOT gate. We know that the absence of something in between two terms, this is going to be ANDed together. Again, the C is ANDed with D. We have another OR gate here. This is a NOT gate on top of the C. Again, the plus symbol here represents another OR gate, and then the B is ANDed with a C. So we can see that we have these two ANDed together. So effectively what we're looking at here is some kind of logic circuit, and it's described by this, what we would say, functional representation, right? So the first thing we need to be able to do is to identify the various letters, right? So I can see here that I have a bunch of different letters, so unique letters. So I have an A, I have a B, I have a C, and I have a D, right? So I have four essential inputs into this particular logic circuit. So, perfect, right? So now the very first step, right, what we need to do is we need to write down our inputs. So we have A, B, C, and D. Okay, and these are all of our inputs. Okay, these are our inputs into our logic circuit. So now the next step really is to look at this particular circuit, and what we need to be able to do is to consider how do we construct this full logic circuit by analyzing this functional expression above. So what we're going to do is I'm going to take different colors representing each of those particular inputs, right? So we'll say that A is going to be a green color, and then so we can see that the input A, so the very first part of this expression up here is we have A or B going into an inverter. So if I take the symbol A and if I pass him down, right, now B is going to be, we'll give B the color blue, and if I take a line from blue and if I pass him up here, now I'm going to draw the gates as black. So I can see that A is going into an OR gate with B. So I draw an OR gate, and now I'm going to continue with just the color black after the initial first gate, right? So we can see that this is A or B, and now what we need to be able to say is that this has to go through an inverter, yeah? So, sorry, let me just get rid of that line there. So what happens next is we can see that the resultant of this OR gate is then passed through an inverter, and now this becomes A or B bar. Okay, so we can see that we've kind of started off with this initial thing of A or B and then the bar above it, yeah? So that's great. Now let's look inside of the brackets here. So we have C ANDed with a D. So if I was to take a different color now, so if we take a kind of a purple color for C, and we're going to pass this into an AND gate with a D, which we take as red. Again, we're going to draw the gates as black, and we're going to say that this is simply going to be an AND gate. And we can see there we have the AND gate, right? And the resultant of this is simply going to be C ANDed with D. So as we start to draw all of these various components, yeah, we can see that we have the A or B passed in through an inverter. We have the A or B not. Now we have the C and the D, and this is passed into, I suppose, an OR gate with the complement of C. So if I was to take the C here and pass C straight into an inverter, what I actually get the far side of this is not C. And now continuing with black after just the initial inputs, I would have C, not C, going into an OR gate with the C and the D. So now I have C, D, or not C. Okay, so I can see now I'm starting to construct. Now I have the full, I suppose, component inside of the brackets. The last thing I need is something to actually represent this B and C up here, right? So again, if we take a very, I suppose, an input signal from B, so if we want to do this, we draw a simple circle like that. We take him down and we bring the line out like this. And then we take a sine or a wire tracing from C and we bring up here. And then we're going to pass this into an AND gate. And the resultant we get out here is B and C. So when I look at this full expression here, essentially what I'm going to have is two different sides, right? So if I was to look at this whole expression here, I could say that I have what's in green here being ORed with the B and the C, right? So I need to be able to take now my input from here and put this into an AND gate with the resultant from what was inside the brackets. And this would then, the resultant of this gate would be A or B bar ANDed with C, D, or not C. And now this actually goes into a final OR gate with the B and the C. And the output of this is simply F. So just a couple of things to note here, right, which is very important. When you're moving along a wire tracing, as we see here, yeah, the BC, and what happens is we need to loop over a wire. When we draw the loop over the wire to clearly show that this is actually the output from this particular gate here. Okay, just like if we were to follow the output of the inner bracket, so the C and with the D and the not C, if I follow that here, I can see that what's actually happening is that we're going underneath this particular loop, yeah? So very, very clear, has to be readable, right? We should always label what's inside of the brackets. So you see here we're naming the gate. Okay, these are our inputs. When we look at the lines are the wire tracings. Right, and this shows us, I suppose, how the signal passes along those particular wires. Right, with F, or the resultant here, being the output of this particular circuit. Okay, so in very brief summary, we have 4 inputs labeled A, B, C, and D coming into these different logic components. We clearly label the gates. We can see the resultant coming out of the gates. And then what we do is we build up this full circuit, and we should be able to, I suppose, see the wires tracings very, very clearly. Okay, so now that we've finished drawing out our circuit, and we understand how to loop over, how to draw these components, how to be very clear with it, all we have to do now is draw a little happy face. And we're done.